Alright, so once again, warm-up number 41 is on the screen. It's number 1, it says write the compound inequality shown by the graph. We have a green graph with an open point at -2, and it's pointing to the left with an arrow at the end. We have a red graph at 1, 2, 3, 4, between -4 and -5, solid point, and that one's pointing to the right with arrow going to the right. For number 2, it says solve, and we have a fraction -4 over x squared minus 4 equals to 1 over x plus 2. And for number 3, it says write the equation of the function, and they give us a coordinate plane, and then they give us a blue line, and I'm going to give you some reference points for that one. Reference point for that line is -3, -4. And let me give you one more, 3, -6. You can use those 2 points, graph your line going through those, and it says to write your equation of the function. I'll give you some time for that. Copy and go. Alright, let's see what we got. Number 1, I think Drina got it. What'd you get for number 1? Solution set of x such that, oh, it's unfreeze. Okay, let it go. Okay. All right. -4.5 less than or equal to x less than -2. Hands, have you got that? That is correct. Why this one equal and not this one? Well, this one's a solid point and this one is not. Okay. Number 2, pass someone, Adrina. She's not here. Who? Raymond, number 2. X equals -2. Hands, have you got that? That is correct. Let's go. And once again, this one you cross multiply, so you should have ended up with -4x minus 8. Cross multiply, x squared minus 4. Get all of these to the other side, which means we add 4x and add 8. Add 4x, add 8. And that gives us 0 equals x squared plus 4x plus 4. And then from there, what 2 numbers multiplied to give me 4 that when you add them give us 4? 2 and 2, which means x plus 2, x plus 2. Set those equal to 0, and we can only get one time that solution, which is x minus 2. Okay. Raymond, pass someone. Number 3. Philip, what you get for number 3?
I got -1 over 3 x minus 5.
Hands, have you got that? That is correct. F of x equals -1 over 3 x minus 5. We always start with our y equals mx plus b for linears. The plus b is our y-intercept, which is -5. It's crossing through there, yes. There it is. And then you needed to pick 2 points, and I'm pretty sure Philip used this one and this one.
Yeah.
Something like that. So that means we go down 1 step. If we go down 1 step, that's why this is -1, and 3 to the right, and there it is. Rise over run. All right, let's move on. Agenda for today. We got warm-up number 41, transforming functions, and tonight's home play is only 1 problem. Only 1. You're like, what? I know. Thank you, Mr. Cute. You're welcome. I got you. You're like, wait a minute. 1 problem? Wait a minute. Oh, snap. Anyways, yeah, it's fun. So, I don't know if you guys noticed, it's Friday, no pop party today.
What?
You're like, what? I was so much expecting that, Mr. Q. Yeah, right. Anyways, so yeah, I postponed it because we need to get to the second part of yesterday's session to make sure we finish strong. But I do have a little activity towards the end, so you'll see that, so like that we can actually see the transformations together, okay? All right, so with that said, copy the Nearpod code. You're going to need that for the notes, PRQZV, and so you can copy the home plate also, because it's not from the book and it's not a play sheet, it's going to be on Nearpod. PRQZV, PRQZV. Alright, so the home plate tonight, look up, and you can get that later on, it's graph f of x squared, f of x equals x squared using the domain from -3, -2, -1, 0, 1, 2, and 3, and they're going to ask you to do 4 transformations. Only 4. Good, right? Yeah? However, before we get to the second part of the session, I want to see your home plate. Get that in front of you. We're going to go over this one, which is graphing f of x equals 2x plus 1 using that domain and the 2 transformations. If you didn't really get to these, hopefully you can follow along as we do these together. And also at this time, could I get the, let's see, the second person in each row, go get graph paper for your row. There you go. And I'll come back to... Alright, here we go. So, last night's home play, I gave you f of x equals 2x plus 1. Is that correct? Alright, and we needed to graph it according to the domain -2, -1, 0, 1, 2. And we need to find f of x. Once again, if you already did this, that's cool. If you had issues with this, then you're following along, yes? So to get the f of x, I substitute these values in here. So what is -2 times 2? That's -4 plus 1. That's -3. -1 times 2 is -2 plus 1. That's -1. 0 times 2 is 0 plus 1 is 1. 1 times 2 is 2 plus 1. That's 3. And 2 times 2 is 4 plus 1 is 5. So if I graph that, -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. Yeah. Yeah. There it is. And those of you that graphed that, I want you to label it on your graph. This is our original f of x. F of x. Alright, but then they want us to do a transformation. What was the first green transformation? What was it? Was it +2? +3? So it was f of x plus 3. So without doing any tables or anything, this is saying to take the original f of x. Do you see the original f of x? Yes. And +3. This is our k parameter. So what is this +3 going to do to all these 5 points? Tell your neighbor, what is it going to do to all those 5 points? That +3. That was good, that was good. Miguel, what is it going to do? What? It's going to move up 3 each of the points. So I'm going to start with this point down here, and I'm going to go up 3 steps. 1, 2, 3, and I'm going to plot my new points. This one, 1, 2, 3. This one, 1, 2, 3. This one, 1, 2, 3. And this one, 1, 2, 3. That is correct. And we're going to graph our new function in green. There it is. Okay. Now we need to label that. We can't label it f of x anymore because it's a new function. So we label it g of x. G of x. So check this out. So the equation for this new one would be this. Look up and label this on yours. G of x. To get g of x, what did we do? We took f of x and we added 3, which means we moved it in the k direction. And that table should look something like this. And let's see, -2, what is the y value? 0. -1, here's my point at -1, what is the y value? 2. 0, what is the y value? 4. 1, what is the y value at that point? 6, and the other one, 8. Okay. Next, they said to do what? F of x. What do we do to f of x? -5? Was it? Yeah. -5. So that means we take the original function. So look up. Original function. For this one, we took the original function. We went up 3 steps, which means, tell your neighbor obviously what's going to happen to the original function now with this one. Oh, and you were gone, and they had picked you to go next, Brandon. Brianna, they had picked you earlier, but you were gone to answer a question. So since you're back, what's going to happen to the function? Down 5. So each of these points 5. 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3. Oh, that's it. My bad. Okay. There it is. Okay. But this new one, we can't label it f of x because that's the original. And then they did one transformation, which is g of x. What can we label this third one? Talk it over with your neighbor. We can't do f or g. What can we label this next one? What can we label that one? Saul, what do you think? What is it? Oh, help him out, Lewis. H, yes, h of x. Let's see, f, g, h. Okay, so that's going to be our h of x equals to that. Does that make sense? Yes? Yes, Mr. Q. So let's get our table for that one. H of x, -2, -1, 0, 1, 2. Let's see, at -2, what is the y value? The y value is -8. At -1, what is the y value? -6. 0, the y value is -4, and I see a pattern. Yes? All right, from 1 to 5, how comfortable do you feel with this so far? Yeah, 5 fourths, 5 fourths, okay. Now, before we move on from here, look what I'm going to ask you to do. I'm going to ask you to do one more transformation. Get yourself a blue pen if you have a blue pen. Here he goes. I'm going to ask you to do the following transformation, still following these 3 that are doing here. I want you to do h of x plus 12. All right, so before you get started though, so like that you can make sure that you are doing it correctly. First question, which of those 3 lines are we going to use? And number 2, what are we going to do to that line? Talk it over to your neighbors. Which of those lines are you going to use and what are we going to do to it? Talk it over to your neighbors. Alright, let's see. Good conversations, man. Everybody's so talkative today. Okay. Valerie, which line are we going to use? The green, the black, or the red? The red one, because that one's labeled what? h of x, yes, h of x. And where is it going to go? Up 12 steps, that is correct. So we go from here, each point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps upward. Yes. Let me do that to this one as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one, 12. This one, 12. And this one, 12. There it is. So, g of h, f of x, g of x, h of x. Tell you never what we're going to label this one. Ricardo. Very good. I of x. All right. I of x. Yes. Wait a minute. F, G, H. Anyway, now we're doing this so I can show you a process when you are focusing on one function and doing a lot of transformations. However, most likely the book, and as we continue on, after the first transformation that they label it g of x, any transformation that's not the original from there, the book is always going to label it g of x. Doesn't matter how many different transformations you do. Just in passing, yes? So, and we don't need to do the table. You know what to do for that. So just to make sure we got it. Let's see, what does 3, -5, and positive 12 represent? The parameter k. Is that correct? Yes? So, according to what we did yesterday, what does k do? If we substitute a positive value or a negative value, talk it over to your neighbor, what does it do to the original function? Positive values, it does this. Negative values, it does that. All right? So to continue on, guys, and just not to make this go a little bit farther, we'll stop right there further. We're going to continue with our session that we started yesterday. I can transform a function using different parameters. So for today, you are going to need, towards the end, like Cornell notes, but right now I need you to get the big graph in front of you. Get the big graph in front of you. All right, at the top left, I want you to write example super Q, and you're going to write graph f of x equals x squared. And copy these three tables, because we're going to use the domain -2, -1, 0, 1, and 2. So copy this one in black, the next one in green, and the next one in red. Give you some time for that. So, this isn't new, but this is our formal introduction to a quadratic function. We've been working with quadratic equations already, but the process is still the same. So let's do our range for this first table. Let's do it together. I'm going to write it right underneath. I'm going to write my original function f of x equals x squared. I'm going to write it again, f of, but in parentheses, missing the x. Just so we can show the work and you guys can see the process. Here we go. What is the first value that I'm going to use? -2. -2. So what is -2 to the second power? -2 times -2 is 4. Next value is -1. What is -1 to the second power? Negative 1 times negative 1 is 1. Okay. Next value, f of 0 equals 0 squared. Of course, it's 0. And now we can actually use a pattern. We're saying negative 2 times negative 2, negative 1 times negative 1, 0 times 0. That means 1 times 1 is 1, and 2 times 2 is 4. Let's plot those. Yes, here we go. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. Sketch your parabola. And if you notice, it's a curve. And as promised yesterday, I said we were going to get to these. Yes, here we go. So, and by the way, this parabola, the same points we're going to be using like throughout the year, so make sure you get used to it, familiar with it. It's going to be one of your BFFs for the year. All right. Are we there? Yes? You're like, Mr. Q, this is simple. Yes, because we've been using some of these before. Okay, we got it. All right, so let's go to the first transformation. Writing utensils down, look up to the screen. So this is a little bit different from what we did yesterday. That's why I wanted to present that today. Here we go. Now, according to the process that I wrote here, it was f of x equals x squared. Or in other words, f of whatever that with whatever squared. So this one, I'm going to write f of, but wait, I can't write f of x. What do I write now? F of x minus 5. So I'm going to change that to green and write f of x minus 5, and whatever I get, I'm going to square that. Okay, so let's see. F of, I'm going to put the minus here because that one is part of the original formula. I'm going to show you in a little bit. Okay, so look up, please. Here goes the process. Ready? What is my first x value that I'm going to substitute in here? 3. Okay. Now watch. Why didn't I substitute it over here? Because this changes. I can't just write the x here because now it's doing something to the x. So what is it doing? What is 3 minus 5? Negative 2. That is correct. What is negative 2 squared? 4. Write that down, please. You're like, what? I know, right? Fun stuff. Let's go to the next one. What's my next x value that I'm going to substitute in here? 4. So 4. What is 4 minus 5? Negative 1. And negative 1 squared is 1. And you're copying this, yes? Good. F of the negative. Notice I've been putting the negative in black because that's part of the formula that I'm about to give you in a little bit, so you can see the parameter. What's my next value? 3, 4, 5. What is 5 minus 5? Which is 0. Finish with the last two, please. All right, next value. Andy, for 6, what'd you get? 1. Thank you. How about for 7? Bree? 4. That is correct. All right, let's plot these. 3, 4. 4, 1. 5, 0. 6, 1. 7, 4. Okay. So, yesterday, we did this. Look up. F of x and then plus a certain number or minus a certain number. But notice that that number was outside of the parentheses of f of x, yes? And this one moved it, you said, up and down. Is that correct? Okay. Today, we have now a number, but it's inside with the x of f of x. Okay? So, think about this one. I'm going to focus on my original, oh, let me label this, my bad. My original one, we said it's f of x, which means my new one is what? G of x, okay. So my original, I'm going to focus on one point just to get started. The point being 0, 0, there it is. So look at the original one, and look at the new one. Talk to your neighbor, let them know what happened to all those 5 points without looking at the table. Just look at the graph. Oh my goodness. Look at the graph and tell your neighbor what happened to all those 5 points to get the green graph. What happened to all those 5 points? So this one, now it's over here. Alright. So I heard someone say, it moved what, Pamela? 5 steps to the right. 5 steps right. Hands if you agree with that? Yes? Okay. So I'm going to make this 5 bold. A bold 5. And we can see that one right here. You guys see it? Yes? Okay. All right. So does everybody see a positive 5? If I get that 5, watch. I'm going to get this 5 from here from the parentheses, and I wrote it over here. You guys notice it's a positive 5? Yes? Why not negative? Because the negative is part of the formula that I'm about to give you. I've been saying that. Yes? Okay. All right. We good with that? Okay. So it moves all the points 5 to the right. So let me write, oh my goodness, computer. I'm going to write this red one similar to the green one, just to make it look like that, so that you guys can focus. Okay? You're saying, but it's plus 4, Mr. Q. I know. So the original formula would have it like this. X minus. Yeah, because the minus is part of the original formula that I'm about to give you. So question. What do I substitute in here that it becomes positive 4? Talk it over with your neighbor, and what would it do to the original function? What would it do to the original function? What do I need to substitute to make it a positive 4? And what's going to happen to the original function? Talk it over with your neighbor. Alright. Let's see. Sky, what would we need to substitute in there? In here, that then it's going to become a plus 4. Negative 4. Yeah, let's see. If I substitute negative 4 in here, what is negative times a negative? Positive. So what value are we going to substitute? Negative 4. This one was positive 5 and it moved it 5 steps to the right. This one is negative 4 and it's going to move it 4 to the left. That is correct. 4 steps left. Why? Because it's a negative 4. So let's do that. This one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Sketch your parabola. There it is. And for right now, let's not fill out the table. I'm just trying to get you guys to absorb this. I know it's stretching your noodle right now, being a Friday and being assembly day, and everybody's like all thinking about already the end of the day. But we need to get to this, guys. That's why I left it for today. All right. So once again, this one moved it. If it's a positive number, 5 to the right. This one was a negative number, moved it 4 to the left. Okay. So, this is a new parameter that we're going to introduce today. This parameter is parameter h, and this is what it looks like. Hold on, before you copy this. G of x equals f of x minus h. This is my general rule, not with h. Okay? However, before you write this, I'm going to give you now the rule with both k and h. Okay, here it goes. Copy this rule, please. G of x equals f of x minus h plus k. Make sure you make a note that this has a minus inside of the parentheses. That's part of the rule. Okay? All right. So, in order for us to make some notes here, we said that the parameter k moves the original function. How? Tell your neighbor, how does it move the original function, the parameter k? Very good conversation. Good. Alexa, it moves in which direction? Parameter k. All right, once again, tell your neighbor where's parameter k going to move the original function? Where is it going to move it to? All right, let's try this again. Newer. K is going to move it what? Up or down. So next to k, I want you to put an up or down arrow. That is correct. K moves our function up or down. With that said, parameter h. Where does parameter h move our original function? Tell your neighbor, please. Where does it move it? Philip. Right or left? So we put an arrow underneath one direction or the other. Now check this out. I'm going to put a little plus sign here for the k. Up is plus, down is minus. How about on the arrow for h? Plus on this side and minus on that side. Yes, that is correct. Now let me give you some numbers so that you can put some meat to this. Here we go. So I'm going to give you an example. G of x equals, I'm no longer going to use a f because we understand that it's going to do that to the original function. And I'm just going to write x minus and then plus. All right. So if I wanted to move to the right, what would I substitute in here? A positive number. So give me a number. 7. Okay, there it is. If I wanted to move up, what number shall go here? 4. Okay, a positive number, yes. If I wanted to move down, what would I substitute here instead of 4? -4. If I wanted to move to the left, what would I substitute in here? But we substituted +7. -7, right? To go to the left, and this is going to transform into g of x equals x plus 7. Does that make sense? All right. So, copy this table because we're going to write some observations according to this table, please. Oh. And, oh, sorry. Let me move this example out of the way. Man, I love technology, right? Am I right? Am I right? Copy this table, please. And it says, predict what will happen by completing the table. We have 3 columns. On the first column it says sign for H. We have plus, plus, minus, minus. Sign for K, plus, minus, plus, minus. And then on the third column it says transformation of the graph of f of x, or the original graph, and then you're going to write your observation there. Copy that. I'll give you some time. To help you guys with that, I want you to get your Chromebooks out or your cell phone, and you can go to, you're going to go to student.desmos.com, student.desmos.com, student.desmos.com. And here's your code. Your code would be 9B7 spacebar PHU. Then it's going to ask you to log in with Google or whatever. Don't do that. Go to where it says don't log in or continue without login, and it's just going to ask you to type in your name to get into Desmos. So there it is. Was everybody able to log in? Yes? Once again, it's 9B7 empty space PHU. Alright? So, for the sake of time, notice this. We're on this screen, yes? But if you go here to where it says next, you go to the next screen, it gives you the original function, it gives you the new transform function, and it gives you a lever for K. If you go all positive values, look what happens to that green graph. It goes in which direction? Yes, and if you go to the negative side, it goes down. Okay. If we go to the next screen, now we have a lever for H. If we substitute positive values, it goes to the... And if you substitute negative values, it goes to the... Yes. And once again, for the sake of time, I'm going to go to the last screen, go to the next screen. This one has both levers. So, what was the first question on the first row? It said if K is what? Positive, and if H is positive, answer the question, what does it do to the original graph? And fill in your table. So when you're done filling this table, you can log out of Desmos. I'll give you some time for that. Alright, let's see. For the sake of time, if H is positive and K is positive, what is that going to do to the original graph? Breathe before we leave, really quick. H positive, K positive, it goes up and to the right. That is correct. So the code works by itself, so you can do that to finish up on your own. But once again, here goes the home plate for tonight. The home plate for tonight is taking f of x equals x squared with a domain from -3 to 3 and doing these 4 transformations. Look up. Notice here this is +3 and it's outside of the parentheses, so this is k +3. This is k -5. This one's inside of the parentheses, so these two are what? H. From 1 to 5, how comfortable do you feel with this so far? 5s, 4s, 5s. Okay, have a good one, guys. Enjoy your home play. See you guys till Monday. Oh, by the way, I'll see you guys at the assembly, hopefully, in a little bit. Bye. Bye.